travel valve on an upstroke is going to seat down, closing off the travel valve. What it does then, it's lifting the fluid that's above it up into our tubing string. As it goes on an upstroke, the travel valve closes, creates a vacuum or low pressure area down below, which means that our standing valve is now allowed to open up. Two things are happening. A vacuum being created here, drawing fluid in, and we have a reservoir pressure here feeding the pump, and it's greater than the pressure that's in here. So because it has a greater pressure, it opens our standing valve and allows fluid to go into the lower chamber of the pump. As it goes on to a downstroke, a standing valve closes, trapping the fluid that's inside of there. When the pressure in between our standing valve and our traveling valve overcomes the pressure on top of our traveling valve will open and allow the fluid to simply be displaced above our traveling valve. Very, very simple. So this pump here is what I call a pump working at 100% efficiency. What I mean by that is as soon as we start on the downstroke, because our fluid chamber or our lower chamber here is completely full of fluid, as soon as we start on that downstroke, the travel valve opens immediately. It's displacing fluid immediately. So that pump is working at 100% efficiency.
So what goes down when, say, you're 50%?
50%, we're only filling up this barrel tube, say 50% of the way, and that's when our travel valve opens and displaces fluid. I'll show you here just real quickly. One thing I want you to take note of though, notice how our travel valve opens and closes. Closes very softly, opens very softly, right? There's nothing abrupt, nothing vicious about it at all. Same thing's happening with a standing valve. It goes on upstroke, flutters a little bit, and then gently closes down.
Yeah.
Pump working at 100% efficiency. We go ahead and we pump it off a little bit. Now we're going ahead and getting incomplete fillage of our lower chamber. This pump here now is only working at, let's say, 70% efficiency, meaning that when it started traveling down, it went down about 30% of the way, technically before that valve went open. This model is false because it shows that valve opening and chattering right away. That's false because you have to remember you have a hydrostatic head of weight keeping that closed.
Yes.
So it's going to go down, and when it basically gets to that fluid, that's when it'll open up that valve. There's no gas in here, just simple fluid.
Yeah.
So that pump is now working at, like I say, roughly 70% efficiency, meaning that only 70% of the time that it's open is when your travel valve opens and displaces fluid is only on that last 70% of the stroke.
Got it. Okay.
So in other words, if you had this held 10 gallons of fluid and there's only 7 gallons of fluid in there, the first 30% fluid pound basically happening.
Yeah.
Last seven gallons is lifting up and putting in there, 70% efficiency. So things to notice though, our standing valve. Remember how that standing valve used to open up nice and easy? Sit there and just kind of lift up and then kind of float down nice and easy?
Yeah.
Now it's sitting there chattering.
Chattering, yeah.
Because we're not filling that chamber full.
Got it.
Okay? That's what basically is happening in a pumped off situation. So your well, I'm assuming you're going 4 strokes per minute.
Yeah.
4 strokes per minute, little 1.5 bore pump. Could realistically probably do 15 barrels per day. Or sorry, 15 cubes per day.
Yeah.
You're doing 2.
Yes.
So you know that right off the bat that you're working that pump roughly at, 30% efficient. 30% of that stroke is having this type of thing happen.
And when you would have a well on tap,
Mm-hmm.
it would just be your standing and traveling valves hitting each other each time, hey? No?
That does not happen. I'll just put that there. What's happening when you're tapping a well, a lot of guys think that you're doing just like what you said, where you're actually hitting those 2 valves together. Well, you can see that physically those valves are not hitting together, right?
Correct.
What's happening is this bushing right here is hitting this guide. When you go down and you tap, that's those 2 parts hitting together. That's causing your tap.
Oh, I had no idea. Okay,
That's
good
what
to
it
know.
is. Those 2 parts are made. When we actually build the pump, we intentionally leave a gap in between our seat plug and our barrel bushing here. Here we have, what, 1/4 of an inch?
Yeah.
We always try to keep that as minimal as possible. Within an inch generally is our rule of thumb.
Yeah.
And the reason why, if we were allowed a pump to tap here, your barrel, being a much thinner material here, especially at the threads,
Would get.
increase the chance of
Chunk.
breaking the barrel off.
Yeah.
Catastrophic failure. If these 2 parts hit and mash up, not so catastrophic, right?
Got it.
So we intentionally build it to hit here. The advantage to tapping bottom is that we are maximizing the compression on our downstroke. If our pump is 10 inches off tap, you can see that the distance in between our travel valve and our standing valve is roughly about 16 to 18 inches,
Yeah.
right? That is an area for gas to compress, right?
Yeah.
The lower that we can go, the more pressure gets created in between our two valves.
Yeah.
I always like to use a bicycle hand pump as an example of that. You take a bicycle hand pump, top of the